Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a code implementation for some of the doubly linked list operations I have told in the previous video in this playlist. If you haven't watched my previous video, just go back and watch it. I will give a link in the description. Fine, let's get started. See here. So this is the implementation of doubly linked list. Okay. First of all, we want to create a node, right? We want to write a class for a node. So this code states that whenever we create an object for this class, it states that there will be three attributes. What are they? They are previous address, data, and current address. Sorry, next address. Okay, this is the object. Object will be created whenever we are creating an object for this class node. Okay, so this is the first observation. This is the first code you have to write. I have clearly stated this code in previous video, right? Now, the next is class T linked list. So this is the class for implementing the operations of the doubly linked list. The first operation I have made is conversion of an array into a linked list, right? So this code also I have clearly explained in the previous video, but still I also explained this code. See here. First of all, def convert self comma array. So I am getting an array as an input, as a parameter also, and head is equal to none. Initially head is equal to none. If len of array is greater than 0, then what should I do? Head is equal to node of ARR of 0. So I am creating a node for the first element. Let's take the array as maybe 1, 9, 7, and then 3, 5. Fine. Now, first of all, I am creating a head which has a node as a type, right? Node as a type. So, see here, one will be created, and here will be none, and here will be none. So, this is my first observation, right? Now, again, current is equal to head. Now, this is my head. Now, current also pointing to my head. Okay. Now, temp is equal to, sorry, I am looping a for loop inside which I am looping from index 1 to the length. Now, temp is equal to node of ARR of I. So, current ARR of I is 9. So, I am creating another node for 9, and then current dot next is equal to temp. Okay. So, current dot next is equal to temp. Let me take this as 200. So, this will be replaced as 200, right? Now, again, current, sorry, temp dot pre is equal to current. So, this is the temp, right? This is the temp, newly created object. Now, its previous is pointing to where? To current. Let me take this as 100. So 100 will be here. Can you observe this? Right? None will be there. Okay. Current is equal to current dot next. Now I am changing my current to here. Can you understand this? Right? Now automatically a link between these two will be created. Now again, whenever I am doing this step repeatedly, new node will be created and a link between them will be created like this. Fine. So this is what this code explains. Now next one is display. So this display is used to print the doubly linked list. How to print the doubly linked list? We can print it in a two ways, right? It is one way. This display is one way. What this display states is we can print in a this way, left to right. That means head to tail. That's what this display function means. Now see here, if not head, print empty linked list and return. Fine. Otherwise, current is equal to head. Initially, place my current to the head. Let us assume this is my linked list. Okay. Here's my head, right? Now I will place current also in this head. Now I will print this one. So my output will be what? 1. Now I will shift current to current dot next. So I will shift current to current dot next. Now again I will print it 2. Again I will shift to here. Again I will print it. So it is 3. See here we are printing what? Current dot val. Okay. Inside the current object, the cur is an object, right? Inside the cur object, we are printing what? This val. It's attribute. Just see here. These are the data members, right? What are the data members? Self.val, self.next, self.pre are a data member. If you don't know the OOPS concept, it's very, very difficult to understand the data structures. Okay. Now, current is equal to current dot x, which means current will move here. Which means what? None. Now, while current, while none, which is false. So, loop will be executed. What is my output? It is 1, 2, 3. Can you understand up to this, right? Now, let's go move on here. The next is display reverse. So this display reverse is used to display in a reverse order. First of all, first step, what we have to do is we want to go to the tail. See here, let me draw 1, 2, 3. So let us assume this is my linked list. Initially, I am here. Okay. Now, what is my goal is I want to move here. Then I want to traverse using the pre, right? That's what I have already told in the previous video. Now, current is equal to head. If not head, print empty list and return. It is a base. It's a edge case I have told you. Now, while current dot next, while element has current dot next, which means while the element has next node, just move on. Then when it will stop, the current will be stopped at here, right? Can you understand now? Yes. Now, while current, print current dot val, comma end this double quotes, and current is equal to current dot pre, which means just print this 3. What is my output? Just print this 3 and move to the this node's pre address. So what is that? This node's pre address? It is 2, right? So print this 2. Again move. Just print 1. Again move, which means none. None is here, right? So it will stop there. Can you understand this whole code? Yes. Now coming to the next coding part. See here, DLL is equal to D linked list of. So this D linked list of is the whole class here, right? Whole class. Okay. Now we are creating an object for this class so that we can access these functions. By using this object, we can access this display reverse, and the convert function. Okay. Now DLL dot convert of 19735. So I am converting this array into what? Doubly linked list and storing the head in what? This head. I am return the head right at last, so that the head will be stored here. Now DLL dot display of head. So now what I am doing? I am just displaying the head. See here, in this head we are passing the argument this head. These two are different variables. Now see here, this function will be displayed. So what we have got the answer? We have got 19735 as a linked list. This is not an array. This is a linked list. We have successfully created a doubly linked list. Now print off. It will takes you to the next line. Now DLL dot display reverse of head. So we are displaying in reverse order. This function will be executed, right? So this is my output. Can you understand till now? Yes. Now it's time to see about the insertion operation. Now see here, this is the insertion and start operation. First we can see this. Let me take another color. Now see here, if insert at start head comma value. If not head, then what should I do? Head is equal to node of val. If there is no head, then what will I do? I just make a node, I create a node and assign to the head and return that head, because we want to return the head at last. It is a first reference, right? Now temp is equal to node of val comma head, which means we are creating a new node by using what? The class, that node class. I already told you, right? We want to create an object for the node class, which creates a node where we have 3 attributes. Now head.pre is equal to temp. Okay, so let me draw here. So let us take this as our linked list. Fine. Now I successfully created a new node. Let us take that new node's value is 10. Now how can I connect it? If I make this one's pre address is 10 and this 10's next address is 1, I successfully connected, right? That's what I have doing here. See here, val comma head. Here node of val comma head, which means this temp has a next address as what? This one. How you can say that it is a next address? You may ask. See here, I may show you. See here, val then comma next, not pre. It is next. So I am passing a value for val and also for next. So that only I am saying that whenever we are creating an object like val comma head, it takes what? It takes val as a value and head as a next. Now hope you understand. Now we have created a link between what? This 10 and 1, where 10's next is 1. Now we have created this link successfully. Now in next line, head.pre is equal to temp, which means we are creating this line. Can you understand now? Yes. Now head is equal to temp. I successfully temp is here. Now temp will be updated here. Sorry, head will be updated here. Now I am returning the head. So my answer will be what? 10, 1, 2, 3. Whenever I want to display, I use this display of head function. Fine. So see here, head is equal to insert at start, head to comma 10. So previously, what is my linked list? My linked list is 1, 9, 7, 3, 5. Here. This is my linked list, right? Now 10 is added, so 10 will be there. That's what the answer is. Now to check whether we done correctly with the previous address, by traversing here towards this side, we can check whether the dot next attribute, this next attribute is correct or not. And then by traversing this way, by using this pre attribute, we can check whether this pre object holds the correct address or not. That's why I am printing this display reverse also. In your real-time application also, you should test like this. Okay. Now let us move on to the next part. Next one is insertion in doubly linked list. We are going to insert in a given position, right? Okay. See here. First of all, we are going to create a function in which def insert of head comma post comma value, which means head, position, and then value. Right now, if not head, then what should I do? I should create a node for that value and assign a tester head. Can you understand it? If there is no head, then the first node will be the head. Then return the head. Okay. If position is equal to 0, what it indicates? It indicates the insertion at start. Insertion at start. So this is the code I have already told you in the insertion start in the previous cell. Can you understand it? Right now, current is equal to head, while current and position minus 1 is greater than 0, which means, see here, in previous video itself I have told you, right, why I am using this position minus 1 is greater than 0 or else position is greater than 1. Both are same, right? And why I am using this current. In previous video itself I have told you, but still I would like to tell you, see here, if there are nodes like 1 and 2, there are only two nodes, this is position 0 and this is position 1. Let us consider. Now I'm asking us to find position 5. I am asking you to find the position 5, and I want to make sure that insert an element called maybe 20 at this 5th index. Whether there exists any position 5, there is no position 5. We have only 2, up to 2. We have position up to 2, but there is no position like 5. So in that case, see here, first of all, my current will be there, then there, then there. So it is what? None. Whether none has any next attribute. Sorry, next attribute. Whether it has any next attribute. No. That's why I am using for cur. Whenever cur is none, it stops. Okay. And then current is equal to current dot next, then position minus is equal to 1. Fine. Okay. Now, if not current, then what should I do? Then I should print invalid position and return head. Right? Can you understand it? When current is none, okay, what should I do? I don't want to do anything because it is what? It is position beyond the limit. So I should return what? Just a head. I cannot insert it. So I will say invalid position. That's it. Okay. If not, what should I do? Okay. Let me take a linked list like this. Perfect. Okay. Now 0, 1, 2, 3. Now I am telling you that position is equal to 2 and you want to insert a value as 20. What should I do? Should move to this node, right? I should move to this node and take a node called 20, then cut this connection, make here and make here as connection and make here as connection and cut this connection and make here. This is the way we obviously do, right? Now see here, so I should stop where? I should stop at 1. At where? At 1 if I ask a position as 2. That's why we are using what? Position minus 1 is greater than 0. Clearly I stated in the previous video, but still I'm doing a recap. Okay. Now temp is equal to node of val. I'm creating a object for the current value so that I can have an attribute. Let us assume this same example. So I have created a value 20 and here is none, here is none initially. Now temp dot next is equal to current dot next. So this is my current, right? This is my current. Now temp dot next, this is my temp. So temps next is what? Let me take this as 300, this is 200, for example. So it is updated as what? 300. Okay. Now, if current dot next, if there exists this 3, if there exists this 3, then only I should change what? This link. Then only I want to establish this link. Why? Because if there is no this node, there is no such node like this. Okay, it is none. Then whether none dot previous is equal to temp is valid or not, it is invalid. It shows what? Error. That's why we want to check whether there is a node like this. Okay, then only we want to go for attachment of link to the pre. That means for a temp. Okay, now current dot next is equal to temp, which means this is the current, right? Current dot next is equal to temp. So I am attaching this node to here. Can I understand this? Right? Now temp dot pre is equal to current. So this is my temp. So I am attaching what? Temp dot pre is equal to current. Fine. Right. Now return head at last. At last what I am putting? Return head. So that head will be written. This will be written. Can you understand this? We are just what? Making 4 alterations in the links. These are the 4 alterations we have done in the links. Hope you understand. Now, head is equal to insert of head comma 7 comma 10. So I am giving what? Head comma 7 comma 10. So position is 7. Position is equal to 7 and value is equal to 10. And what is my linked list? Previous linked list. My previous linked list is 10, 1, 9, 7, 3, 5. So this is my previous linked list, right? Now, whether there exists a position called 7? No, because here 0, 1, 2, 3, 4, 5. So totally there are 5 positions, and we can also insert at this 6th position. We can also insert at the 6th position, but we cannot insert at this 7 or 7 more positions, right? So what is my answer? Invalid positions. Invalid positions. Okay, we may change. Okay, we may change and see what's the answer. Okay, let me modify this. Like, let me give this value as 20 and this value as 4. Fine. So, enter. See here, where's the value? 10, 1, 9, 7, and at the 4th position, what is the value? It is 20. So successfully inserted, right? Now, let us see the last insertion operation, insertion at end. Okay. Now, insert at end, head comma val. So we are getting 2 arguments. What are they? Head and val as a parameter. Now, if not head, then head is equal to node of val. So if there exists no head, then what we do? We will create a new node and make that such a head. That's it. And then return that head. Else, if that's not the case, then current is equal to head. Okay, let me take a example so that it will be more clear. Now, this is the example. Now, where should I traverse and stand such that I can insert a node like this? Let me take this node and I want to insert this node, right? So where should I stand? If I stand here, I can easily insert it, right? In previous video also, obviously I told this, right? So while current dot next. So this node does not have any next node, right? So while a node does not have any next node, then I should stop. Until that, go on. Okay. So initially my current is here. Now my current is here. Fine. Now I'm creating a new node. Okay. Let me take this as 4. Now here also none. Here also none. Current dot next is equal to temp. So this is the current, right? So this is attached here. Fine. Now the second step is I want to make a connection like this also. So I am just putting what? Temp dot pre is equal to current. Now just return the head. That's it. So I'm returning where? This one. So see here, head is equal to insert at the end, head comma 10, then DLL dot display of head. So I am displaying the head. So this is my head. Okay. Initially, what is my value? Sorry, let me run it because I have changed the value rate 20. So see here, 10, 1, 7, sorry, 9, 7, 20, 3, 5, and 10 is added extra. 10 is added extra because see here, this is the initial linked list, and now my final linked list is like this. Can you understand this? Right? Okay, let us move on to the deletion operations. So, first one is delete at the start. So, deletion at start of head. Okay, and if not, then return none. Fine. If there is no head, then what should I do? It's simple job, right? Already we don't have any node. Just return. We don't want to delete anything. Now, temp is equal to head. Head is equal to temp. Head not next. Let me take a node here. Okay, so this is my linked list. Now, initially, here's my head, right? Here's my head. Now, I just take this head as my temp. Okay. Now, I'm just moving my head here. Now, what's my next step? I want to take this connection, remove this connection where now current head is pointing towards the temp. Now, I will delete this temp. That's what this two line states. Can you understand this, right? Now, return the head. Now, return the head. So, what is my linked list? It is 2 and 3, like that. Okay. In previous, we have got what? 10, 1, 9, 7, 23, 5, 10. So, this is my linked list. Now, what is my answer? My answer will be this 10 will be deleted. This all will be my answer. So, let me execute this. Yes. Can I observe this? Right? Now, let us move on to the deletion at the position. Fine. Now, we are going to see about deletion at a certain position. Okay. So, def delete of head comma position. So, we are getting as parameter as what? Head and position. Now, if not head, what should you do? Return head. It is simple job. If head is not equal to none, then what should we do? Just return. That's it. Okay. Now the next step is if position is not equal to 0, equal to 0, then what should we do? It is like what? Deletion at the start. I already told you, right? What is meant by deletion start at the previous cell. So I don't want to explain this code. Now current is equal to head. If this is not the case, then we want to take current is equal to head. Let me take this linked list. Now current is facing here. Now while current and position minus 1 is greater than 0. Let me take position as say it is 0, right? It is 0, 1, 2, 3. Let me take position as maybe 2. Simple 2. And then see here. I want to delete this 3. Otherwise, let me take position as 3. We can see the edge cases also. Position is 3. So I want to delete this 4, this node. Fine. So to delete this node, I have to stop here. I want to traverse up to here. Then it is easy to delete this 4, right? That's why what I am doing here, position minus 1 is greater than 0, which means if position is 3, then I want to traverse how many times? 1 and 2 times to achieve this here, to achieve my pointer here. So what I am doing here, while current and position minus 1 is greater than 0. Okay, but why I am using this current? Because if my position is false, like it is at maybe 5, then this fourth index will be none and my pointer will be standing here at where? At none. But whether none has next attribute? No, right? None don't have any next attribute. So in such case, it is 6, 6. So in such a case, we face an error. Okay. For 6, we want to go up to what? 5. But at 4 itself, it is what? It is none. So at this time, we will face an error. So to avoid that null pointer exception, we are just using what? Current. While current. Current is not equal to none. Now current is equal to current dot next and position minus is equal to 1. Now if not current, which means see here, if I am like this is my linked list. Okay. Now I am standing here at none. Whether I want to do anything? No. No, I don't want to do anything. I want to delete this next node, but there is no next node. So, okay. So also if I am standing here, whether I want to delete any next node, already next node is none. Why we want to delete it? So leave it. So that's why if not current and or if not what? Current dot next. Don't do anything. Just return the head. Can you understand this? Okay. Now temp is equal to current dot next. Okay, let us come to this back to this example. Now here points my temp and this is my current, right? Okay. Now, current dot next is equal to temp dot next. So I am updating this next address as what? None. Can I understand up to this? Right. Now, if temp dot next is if temp dot next, which means if there exists temp dot next, there's none. Okay. So we don't want to execute it. But if there exists, then only I want to do what? Temp dot next dot pre is equal to current. If there exists a node like one, then I want to make this link to here, right? I want to make this link to here. That's why I'm checking. There may be case like we don't have next node. That's why I taken the position as 3 to show you this edge case. Now delete temp. So I'm deleting this temp. Now return the head. That's it. Simple, right? We are just taking this link and connecting here and taking this previous link and connecting here. If there exists, then next. And we are deleting this step. That's easy step. Okay. So head is equal to delete of head comma 3, then dl dot display of head, then print and display reverse. So let me run this so that we can know what is the output. Okay. Initially, what is my linked list? 197, 20, 3, 5, 10. So this 20 is at where? Third position. So this 20 is removed here. Can I understand up to this? Right? Now, it's time to move to the last part. What is the last part? It is the deletion at the end. Fine. See here, delete at the end of head. If not head, just return none. I already told you it is simple step. Now, if not head dot next. Here, if this is only the node in my linked list, then I should delete this, right? So delete this and return what? Return none. That's it. Right? Now, current is equal to head. So let me take a node example. Okay. Now current is equal to head. So this is my head, and now current is also facing here. Now to delete this 3, where should I stop this current? At this 2, right? To delete this 3, obviously I want to stop at this point so that I can remove this 3. Fine. That's why I am checking what? Current dot next, which means current dot next. Current dot next. Can I understand this? If current next is the last node, how we can find the last node? Last node have what? The next attribute is none. Next is equal to none. So this is what a last node. So last previous node is what? Previous last node is what? The next node is none. If there not exists next node, then it is the second last. That's why we are using current dot next. Now current is equal to current dot next. Okay, we are just traversing this current. So let me take this as current. Now current will be here, standing here. Now temp is equal to current dot next. So temp is equal to current dot next. So this is my temp. Let us assume this is my temp. Now current dot next is equal to none. So I am making sure current dot next to none. So this will be facing to what? None. Now I will delete this temp and I will return the head. So what is my answer? It is 1, 2. Can I understand? Right? Now head is equal to delete at star and at the end head. Now DLL dot display and reverse display. That's it. Now let me run this. Here initially what is my node? It is 19735010 and at last 19735. Okay, at last in the end we have inserted some nodes and deleted those same nodes, and it results in the same linked list we have created at first. Okay, anyhow, so this is how we want to implement the linked list insertion, deletion, and print and traversal. I have covered much more topics in linked list, like singly linked list and doubly linked list in playlist. Still we have only one topic, circle linked list. I will tell you in the next video. So stay tuned. Thank you.